Imagine for a moment you are walking down a quiet street late at night. In the distance, a single street lamp flickers, not randomly but in a strange, deliberate pattern. Blink, 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 pause, blink. It almost feels like a code, a message being sent from an unseen hand. Now lift your gaze from that lonely street lamp and cast it upwards, towards the endless, glittering canopy of the night sky. What if a star, a colossal ball of fire trillions upon trillions of kilometers away, was doing the same thing? What if it was sending us a message, not in words but in pulses of light, a cosmic Morse code broadcast across the vast, silent emptiness of space? This isn't just a flight of fancy from a science fiction novel. It's a genuine mystery that has captivated astronomers and dreamers alike, forcing us to ask one of humanity's oldest and most profound questions. Are we alone? The universe is full of rhythms. Stars pulsate, planets orbit in predictable dances, and galaxies spin in majestic slow-motion pirouettes. We've become rather good at understanding these cosmic beats. We can predict eclipses to the second and chart the course of comets across centuries. But every so often, the cosmos throws a curveball, something so utterly bizarre that it defies our neat categories and challenges our understanding of the fundamental laws of physics. It presents a puzzle that isn't just about numbers and charts, but one that tickles our imagination and speaks to our innate curiosity. This is the story of one such puzzle, a star so peculiar, so baffling in its behavior, that it made scientists around the world sit up and pay very close attention. A star that doesn't just twinkle, it blinks. Let's give our mysterious star its official name, its cosmic address. It is known as KIC 8462852. I know, it's not the most poetic name, more like a telephone number than a celestial beacon. The KIC stands for Kepler Input Catalog, a massive list of stars that were monitored by NASA's Kepler Space Telescope. This particular star resides in the constellation Cygnus, the Swan, a distant neighbor located some 1,470 light-years away from us. This means the light we see from it today began its journey across the cosmos nearly 1,500 years ago, around the time the Gupta Empire was flourishing in India. For most of its observed life, KIC 8462852 behaved exactly as a star of its type, a bit larger and hotter than our sun should. It sat there, shining steadily, just one among billions in our Milky Way galaxy. But then, it started its strange performance. Our story's silent hero is a machine, a marvel of engineering called the Kepler Space Telescope. Launched in 2009, Kepler's mission was simple in concept but monumental in execution: to stare unblinkingly at a single patch of the sky, monitoring the brightness of over 150,000 stars simultaneously. Its goal was to find exoplanets, planets orbiting other stars, by detecting those tiny regular dips in starlight caused by a planetary transit. For 4 years, Kepler diligently collected data, a river of information flowing back to Earth, carrying with it the secrets of distant solar systems. This data was so vast that professional astronomers couldn't possibly sift through it all on their own. And so, the Planet Hunters Project was born. This was a brilliant initiative in citizen science, inviting ordinary people from all walks of life to log onto a website and visually inspect the light curves that Kepler had generated. These volunteers became cosmic detectives looking for those telltale dips that the computer algorithms might have missed. It was these citizen scientists, people like you and me, who first flagged KIC 8462852 as something strange. They kept marking it as bizarre, interesting, and weird. The patterns didn't fit the clean profile of a planet, the dips were too deep, too asymmetrical, and they didn't repeat. The data was so unusual that at first, many assumed it had to be a mistake, a flaw in the telescope's instruments, or an error in the data processing. However, after rigorous checks, the scientists confirmed that the data was real. The star was indeed dimming in this wild, unprecedented way. Faced with this perplexing data, scientists did what they do best. They started brainstorming. The first and most plausible natural explanation was a massive swarm of comets. Imagine not just one or two comets like Halley's or Hale-Bopp, but a gigantic herd of them, thousands or even millions, traveling together in a highly eccentric orbit around the star. As this cometary swarm passes between us and the star, their collective mass could create a large, irregular cloud that blocks the starlight. This could explain the messy, asymmetrical dips in the light curve, as the cloud wouldn't be a solid object but a diffuse and clumpy collection of debris. This idea, known as the disintegrating comets hypothesis, was the leading contender for a while. It made a certain amount of sense. However, this theory also had its problems. One of the biggest issues is the sheer amount of material required. To block 22% of the light from a star this size, you would need an absolutely colossal number of comets, hundreds of giant ones perhaps, all passing by at just the right time. Another natural explanation that was considered was a massive planetary collision. Imagine two large planets or perhaps a planet and a very large moon smashing into each other. When natural explanations begin to falter, the human imagination naturally drifts towards more unconventional ideas. And in the case of Tabby's star, the most sensational and captivating idea was that of an alien megastructure. This possibility was raised by astronomer Jason Wright and his colleagues, who pointed out that the star's light curve was consistent with what one might expect to see from a Dyson swarm. This is a hypothetical concept, first proposed by the physicist Freeman Dyson, describing how an advanced alien civilization might harvest energy from its parent star. Instead of a solid sphere, a Dyson swarm would be a massive collection of orbiting solar collectors, a giant, partially completed power station in space. Think of it like this. As a civilization becomes more technologically advanced, its energy needs grow exponentially. Eventually, the energy available on its home planet might not be enough. The ultimate power source in any solar system is the star itself. A sufficiently advanced civilization, Dyson theorized, could build a vast constellation of structures to orbit its star and capture a significant fraction of its energy output. From a distance, this swarm of artificial objects would look like a chaotic, clumpy cloud. As it orbited, it would block the starlight in a complex and irregular way, creating a light curve that could look remarkably similar to what we see from Tabby's star. This idea, of course, is pure speculation, but it was a thought-provoking one because it fit the strange data so well. Now, before we get carried away and start preparing a welcome basket for our new galactic neighbors, it's crucial to embrace a core principle of science, famously articulated by the great Carl Sagan. Extraordinary claims require extraordinary evidence. The idea of an alien megastructure is about as extraordinary as it gets. While it's a fun and exciting possibility to consider, it should always be treated as the hypothesis of last resort. We must first exhaust every single conceivable natural explanation, no matter how exotic or unlikely it may seem, before we can even begin to seriously entertain the artificial one. One of the biggest arguments against the alien megastructure hypothesis is a simple philosophical one known as Occam's razor. The Search for Extraterrestrial Intelligence, or SETI Institute, even pointed its powerful Allen telescope array at Tabby's star, listening intently for any artificial radio signals that might be emanating from the system. Furthermore, the dedicated search for signals from Tabby's star has, so far, come up completely empty. So, while the idea of a Dyson swarm provided a fascinating thought experiment, and spurred a great deal of public interest in further study, the scientific community has largely moved on from it as a leading explanation. It remains a remote background possibility, a what if that reminds us to keep an open mind. But the real work of science continues, focusing on the more plausible, if less sensational, natural causes. The truth about Tabby's star is likely to be something we haven't thought of yet. A new piece of astrophysics that will be just as wonderful in its own way as the discovery of aliens. So if it's not comets and probably not aliens, what else could it be? As more data has been collected, especially after the star started dimming again in 2017, a new leading theory has emerged, one that is less about giant solid objects and more about plain, simple cosmic dust, but not the kind of dust you find in a comet's tail or from a planetary collision. The current thinking leans towards something called circumstellar dust, which is dust that is orbiting the star itself, not just passing through. Let's use an analogy from right here on Earth. Imagine you are looking at a bright lamp across a room. If a single, solid object like a book passes in front of it, the light dims uniformly and predictably. That's like a planet transit. Now imagine someone has just finished sweeping the room and has kicked up a big cloud of dust. The light from the lamp would flicker and dim erratically as thicker and thinner clumps of dust drift in front of it. This is closer to what might be happening at Tabby's star. The something blocking the light isn't a solid object, but a vast, translucent and incredibly lumpy cloud of fine dust particles. It's like a collection of giant cosmic dust bunnies orbiting the star. But where did this dust come from, and why isn't it hot? This is where the theory gets clever. When astronomers looked at the dimming at different wavelengths of light, they found that blue light was being blocked more than red light. This is a crucial clue. This effect, known as Mie scattering, is what happens when light passes through particles that are very small, like the fine dust in smoke or aerosols. It's the same reason our sky appears blue and sunsets appear red. This discovery strongly suggests that whatever is blocking the light is made of fine dust, not large solid objects like comets or alien megastructures which would block all colors of light equally. Since the initial discovery, a global community of astronomers, both professional and amateur, has kept a close watch on Tabby's star. The American Association of Variable Star Observers, or AAVSO, coordinated a crowdfunding campaign to secure continuous monitoring time on a network of telescopes. This has allowed us to catch the dimming events in real time, which started happening again in May 2017. These new observations have provided a treasure trove of data, allowing us to dissect the star's behavior with unprecedented detail. We have been able to watch the dips unfold across the entire spectrum of light, from ultraviolet to infrared, giving us powerful new clues. One of the most significant findings from this new data is the confirmation that the dimming is indeed wavelength dependent. As mentioned, blue light is blocked more effectively than red light, strongly pointing to fine dust as the culprit. This has all but ruled out the alien megastructure hypothesis for most scientists, as large, opaque objects should block all colors of light equally. Adding another layer of complexity, analysis of historical photographic plates of the sky, some dating back over a century, has suggested that Tabby's star has not just been dimming erratically in the short term, but has also been gradually fading over the long term. According to some studies, the star has decreased in overall brightness by about 20% over the last 100 years. This is a truly bizarre behavior for a stable F-type main-sequence star. This long-term dimming is a separate puzzle from the short, deep dips, and it's not clear if the two phenomena are related. The story of Tabby's star is a perfect illustration of science in action. It is not a straight line from question to answer, but a winding, messy, and exhilarating path filled with debate, collaboration, and the constant revision of ideas in the face of new evidence. It began with the keen eyes of citizen scientists, was propelled into the spotlight by a bold and imaginative hypothesis, and is now being meticulously pieced together by a global effort of dedicated observers. It shows us that there are still fundamental discoveries to be made, not just at the edge of the observable universe, but right here in our own galactic neighborhood, among the stars we thought we knew. This single peculiar star has challenged our models of stellar evolution and planetary systems. It has forced us to consider new and exotic astrophysical phenomena that we hadn't previously imagined. Perhaps there are new mechanisms for how stars and planets interact, or new ways that dust can behave in a star system. The ultimate explanation for Tabby's star, when we finally find it, will likely teach us something new and fundamental about the cosmos. It might not be aliens, but the reality could be just as fascinating, a new type of celestial object or a new stellar process that will be added to the textbooks of the future. This is the true reward of scientific inquiry. The universe is under no obligation to make sense to us. Its vastness contains more wonders and more strangeness than our philosophies have yet dreamt of. KIC 8462852 is a humbling reminder of that fact. It sits out there in the darkness, nearly 1,500 light-years away, continuing its strange, flickering dance, indifferent to our frantic attempts to understand it. It is a cosmic beacon of mystery, inviting us to keep looking, to keep questioning, and to never lose our sense of wonder. For every puzzle we solve, the universe presents us with a dozen more, each one more profound than the last. So the next time you look up at the night sky, past the familiar constellations and the steady glow of the planets, remember Tabby's star. Remember that among those countless points of light, there are mysteries that are actively unfolding, puzzles that are waiting for a clever and curious mind to solve. The cosmic detective story is far from over. In fact, we have only just read the first chapter. The search for answers continues, and the invitation to wonder, to explore, and to discover is open to us all. The cosmos awaits.